Hello, today we are graphing variables. By variables, I mean that we are graphing independent and dependent variables. The independent variable is a variable that an experimenter changes within an experiment, and a dependent variable changes because of the independent variable. Typically, our data that we've gathered throughout the experiment is located on a t-chart, where the independent variable, or the variable that the experimenter has control over and changes, is in the left-hand column, and the dependent variable is to the right. So here our experiment is the effect of the color of the light on the height of the plant. So you have the setup pictured below. You have a white light, a red light, and a blue light, all exposing different, all on same types of plants. What the experimenter is controlling, or the independent variable, is the color of the light, red, blue, and white, and then it is affecting the height of the plant. So at different, when the plant is exposed to different lights, the plant will grow to different heights. All right, so that is the height of the plant would be the dependent variable. Here you have your trial 1, your trial 2, and then typically you average out the trials, and that is what you end up graphing, is the average. All right, when you are graphing the data, the purpose of the graph is to show a visual representation of the data so that readers or audiences can see the relationship between the two variables very quickly and easily. So in this case, you would have the independent variable would be the color of the light, and it would go on the x-axis, and the dependent variable would be the height of the plant, and it would be on the y-axis. The title of the graph always has to show a relationship between the two variables, the independent and the dependent variable. So it would be something along the lines of the effect of the color of the light, which is the IV, on the plant growth, which is the dB. Here's a sample problem. Here you have daily sun exposure, so a plant is exposed to the sun for a certain amount of hours for a certain amount of days. And then the experimenter is clearly measuring the height of the plant after the certain number of days have passed. So what would be the independent variable? Would it be daily sun exposure or plant height? What would be the dependent variable? Daily sun exposure or plant height? I hope that you chose independent variable is the daily sun exposure, and that leaves the plant height as the dependent variable. So the next question is, where would you put these on the graph? Well, as you know, the independent variable goes on the x-axis down here, and the dependent variable goes on the y-axis up here. So in our next scene, kind of picture this in your head. In our next slide, we will present the answer. All right, so here you have the daily sun exposure in hours. That is your independent variable on your x-axis, and your plant height on your y. Right. Every graph should come with a title showing the relationship between the IV and the dB. So here you have the effect of the daily sun exposure on the plant height. All right, then we are going to plot our points. Notice that we set up the graph so that the range of the data goes from 0 to 11 hours, or 0 to 11 centimeters. So our graph goes from 0, which would be here, all the way up to 11, and it takes up most of the space of the entire axis. In the same case on our y-axis, we have our x and y properly labeled with units, and then we put dots where the data is. So at 1 hour, the plant grew 3 centimeters. 1 hour, the plant grew 3 centimeters. At 3 hours, the plant grew 6 centimeters. At 3 hours, the plant grew 6 centimeters. At 5 hours, the plant grew 7 centimeters. At 5 hours, the plant grew 7 centimeters. So that's how we filled in the graph. All right, so that takes you the steps through data collection, organizing your data in a data chart, putting the independent variable and the dependent variable in the right positions on the data table, and then from there, allowing your audience to visualize the data by presenting the data on a graph. And then you can very easily see that the plant exposure peaks at about 9 hours and then And then after more than 9 hours of exposure, it actually starts harming the plant. I hope this was useful.